Hi, welcome back to our second video in the CwC Sumo game that we're trying to build. What we did last time was we made a focal point that's a game object that's held like right in the center of our game so that our camera can both rotate around it and for our player on their player controller script can always find that position. It's position forward, right, and to move towards that so that whenever we move back and forth, no matter what position our camera's in, we're always going towards it. So today we're going to be working on building our enemies out. Obviously, game's not super fun. It's not really fun at all without an enemy. So let's just jump straight into it. Over here in my hierarchy, I'm going to go ahead and create another 3D object, and it's going to be a sphere, just like we did last time. This sphere is currently, looks like it's being held right inside of our player, but we're going to move it in just a second. Let's go ahead, actually let's move it now. So hold Option, and I'm going to move it just up this way a little bit. How about we do X of 0, let's change it on our Z, let's put it at like 6. There you go, that might be better. And I think I'm going to use the same numbers for its scale. So 1.5, 1.5 on the Y, and then 1.5. Let me double click here in the hierarchy and make sure we can find it. And that looks pretty, yeah, that's really great. And a Y of 0.1 just puts it right above the ground, which is spot on. Let's go ahead and change the name as well in the inspector, and we'll call this enemy with a capital E. And let's give it a texture as well. So I'll go back into my course library, textures. You can tell I found a picture of a sumo wrestler. I kind of want to add to like my enemy here, but I'll stick with you guys here, and let's do one of these. I don't know, what about this one? Yeah, that's pretty good. I like the contrast between the black and the white. So it currently has a sphere collider. I think because we're using rigid bodies to like hit and things like that, we want physics to work. Let's go ahead and add component. Rigid, oops, I was spelling out the variable name. Rigid body. Looks pretty good. Let me test this out and see if I can move towards it. Alright, so first thing is if I press up, I'm going to go straight up. So instead of doing that, I need to rotate. I gotta get my camera lined up, sort of. So now when I press up, well, I hit it. It works. So it is spinning, and you can tell it's moving quite slowly. Goodbye. Alright, so adding that rigid body helped. But I think instead of us just having like a soft sort of hit on it, we want to have like a bounce off of it. So you know what? Let me just for the sake of us seeing what it looks like, I'm going to take this. Maybe not here. Maybe if I drag it, let me find some numbers. I just want to set it up so that it's like right in front of our player. I'll change that Y back to 1. Where did it go? Oh, it's like right inside our player. I don't want to go there. I want to go here. There you go. Something that's just like right north of our player. So maybe -4.6 and 6.3 on the Z, something like that. And for the sake of us seeing what it really feels like, I'm going to try it again. I'm going to go as soon as the game starts. I'm going to press up. Yeah, I mean that hit is pretty uninspired. It just like softly hits. So what controls the way that these two things are colliding is something called a physics material. And a physics material is something that we can apply almost like a texture to an object that controls, well, the physics. I guess it's better to see it than to just explain it. So I'm going to create a new folder. We'll call it capital P physics. Now you don't have to spell this exactly because we're not using this as a string, but physics material, and inside that folder, I'm going to now create a physic material right down here. And I'm going to go ahead and name this before I click off of it. And I'll just call it bounce. So the options that it gives us over here are a couple different ones. There's a dynamic friction and a static friction. And the difference between these is, friction being when two objects collide, like, the resistance between the two. Dynamic friction is the friction of an object when it's moving, and then static friction is the friction that it generates whenever it's stationary. And usually they're going to be the same in the real world, but for some things you might want stationary objects to have higher friction when it's not moving, to rub a little differently than if it was moving. But bounciness, well, you can guess what bounciness makes it very bouncy. So let's set our bounciness, I don't know, maybe like 10. And then there is something else that's worth knowing, is these friction combines and bounce combines. And this is basically like a mathematical way of processing the difference between its top value and its lower value. So right now if we have this bounce combine on one of our objects, one of them will be bouncy, the other one will not. But you can look at the amount of bounce given between two objects, and you can take the minimum, so you make this the least amount of bounces possible. You can do the maximum amount, or you can do one called multiply, which really adds a lot more bounce than just what you're giving here if both of them have this object on it. So we're going to use multiply because we want it to be a very bouncy material. So use multiply for a stronger effect, minimum for the least, and an average is what you would sort of expect. And multiply is actually probably even more than maximum here. So let's add this material onto both our enemy. I'm going to just do it here in the hierarchy, and onto our player. And the way that I check that is if I click on our name in the hierarchy, on the collider, we will see the bounce material. Check the enemy and bounce. So let me press play. See if it feels a little bit bouncy when we make contact. There you go. That feels better. It gives a little push between the two, opposed to how static it was before. Great. So our next step will be to make a script that controls our enemy so that it can move towards us. We want it to always be coming at us. So we'll do that first, and then we're going to make a spawner to start spawning these. So since we're making a script, I'm going to go back here into my scripts folder. I haven't saved recently, so I'm going to hit Command S just to get in the habit of doing that. And I'm going to create a new C# script. And we'll keep it simple. We'll call it enemy and press return. And open it up inside Visual Studio. So I'm trying to think, what do I need for an enemy to come at me? Well, it needs speed, and we want it to hit us, so we need to think about its rigid body. Like we're going to have it move. Sorry, since it's moving, we're going to be using the rigid body. The hitting is actually the collider, but the pushing of the sphere, adding force to it, is going to be the rigid body. So I'm going to make some variables to hold those. Line 6, I'm going to press return. I'll do public speed. Oh, sorry, I need to see what type of, let's do a float and speed. Now let's go ahead and initialize this up here at the very top. We're going to go ahead and set this value. And I'll just go with 10. That's my generic go-to number. I want to get rid of this line 9 comment line. Then on line 8, let's go ahead and we know we need a rigid body. Let's go ahead and we're going to initialize this in the start method. So we're going to go get that rigid body. So let's create a private rigid body, and we will call it enemy RB. Done. And so in the start, we need to go get that. So enemy RB equals get component. Since this script's going to be on our enemy rigid body, and then we have an argument right after that, and then semicolon. So when we start, we will get that that player's rigid body. I guess another thing we should be thinking about is we're going to be needing to move towards the player at all times, right? Because our enemy is moving towards the player, so I guess we'll need to know the player's position. So up here at the very top, let's create a variable to hold our player, and we'll do let's do the same thing where we'll go get the player by finding the player. So private game object, since we're going to be looking in the hierarchy, and we will just call this player. There you go. And in our start method, let's initialize this too. Let's go find the player when the game starts. So player equals game object dot find it. Go find it, and then we need to open up some parentheses, and it's a string name. It's a specific name. So open quotations, and the name, based on what I see here in my hierarchy, is player with a capital P. So it needs to be spelled exactly the same. Go find my player, and then at the end, let's put a semicolon. So the argument for game object.find is the string of player. That's why these are inside parentheses. It's an argument. Okay, so what we want to do is to take and add a force to our player's enemy's rigid body, and always having it going towards our player. So let's start with asking where we want to do this. We don't want to do it only in the start. We want to have our enemies always moving. So we'll do it inside of the update. So enemy rigid body, so we're applying a force to the rigid body. So add force. And open it up, we have an argument. We have to decide in which direction it's going to go. And this is telling us that the argument needs two things. It needs to know which direction and how much force. We know that our force is going to be speed, but we need to decide the direction. And the direction is going to be towards our player. So, but we want to kind of close the gap, like between our player's position and our enemy's position. So we'll say player dot transform dot position, and then we want to take that and subtract the distance between and you know, player.transform.position is a vector 3. It's an xyz. So that satisfies this first part of the argument. Minus our the whatever game object this is on, which is our enemy, our transform.position. Not that. Okay, so that gives us the direction we're moving, and then we just need to say at what force. So we would want to say at speed, and then a semicolon. The only problem with us doing that is it will, you know, it follows like normal math rules. And if you know normal math rules is that you multiply first, then you know you do the subtraction and all these kind of things. We don't want to. We want to find this number here first, this vector 3 first before we multiply by speed. So I'm going to take and put some parentheses, an open parentheses for the player, and this. So whatever is in the parentheses will happen first. So that should be okay. Let's go ahead and save this and go back into Unity. Now we have not applied this script yet to our enemy. Let's check and make sure we didn't do that. No, we didn't. And so I will just add component. Let's do it that way. Enemy. Here's our enemy script. And yeah, we have a speed of 10. So I'm going to press play and see if it comes towards us. Oh, it does. Now, something that's worth noting is that it starts off actually kind of slow, and then it gets faster. I'm sorry. Yeah, it's going really fast. The momentum builds up. But what's happening is this is a number here that is bigger the further away our player is from our enemy. So that number is faster when it's multiplied by speed. So it's faster the further away it is from us, and then it gets a little bit slower as it gets closer. So in order to resolve that issue we had with the distance playing with the overall speed, or the velocity rate at which our enemy is coming towards us, we're going to just add a little line of code here. So we're going to add a dot normalized here, which basically says it would take an average speed, so the enemy will always move towards us at the same speed. So that's what normalized does, is it gives it a even flat number no matter what the distance is. So we'll save that and give it a chance to compile. Let's test it out and see if that made a difference. Yeah, that feels a lot better in terms of speed. I'm gonna try to rotate, and it looks like my enemy is still coming at me. I want to try to get away from him a little bit here. Oh. Yeah, but it managed to push me off first. So great. So that feels a lot better for an enemy. He's pretty aggressive, and it's just kind of like rolling around. There is a little bit of a problem. So let's clean this up in our script, because this is fine right here, but instead of having this super long line of code, let's just make this into we know that it's a vector 3, let's make it into a variable. So let's just, the line above, we'll make a vector 3 to hold that. Vector 3. And we'll give it a name. Let's call it look direction. And set it equal to, and we'll make it equal to all of this part right here. So that player dot transform stuff. And put a semicolon there. So this will hold this information. So we'll do look direction there. Save that. That just once again makes our code a little more flexible. There you go. So we just place it on the line above. It's all good. So I guess our next thing is we want to start actually, this is controlling our enemy, but we want to start spawning the enemy. So in our hierarchy, let's make a spawn manager, something to hold our spawn script and from which our enemies will spawn. So I'm going to create an empty, and in the inspector, I will call it spawn manager. Press return. Make sure that name is saved, so I'll know it's saved because in the hierarchy, this name matches this one right here. And let's go ahead and add a new script in our scripts folder. C# script. And let's call it Sumo spawn. I'll just call it Sumo spawn for now. That looks good. And let's open that in Visual Studio. Give it a second. We got to remind ourselves to add that onto our spawn manager when we're done. Well, so we're going to be spawning. So the things I know that we will probably be using or instantiate at some point, and variable wise, we're going to need to know like positions and what we're spawning. So let's start with that. Like, what are we going to spawn? And I'm going to press return. Well, we know we're going to be making we're going to be spawning our enemy prefab. So public game object, since our enemy is a game object, and we'll just call it enemy prefab. All right, that looks good. And I guess how about when the game starts, we'll make a copy. So inside of our start method, let's you do instantiate. And what are we instantiating? Well, we're instantiating our enemy prefab. And we probably, for now, let's just put it in the world and we'll change this number. We'll make this a variable in a little bit. So a new vector 3. So we're going to tell it x, y, z where we want it to go. And for now, let's move it to 0. So in the middle, except let's put it in front of our player. So let's put it at 6, kind of like where we moved our last one. So we need to know in our instantiate, we need to know what, where, and the last thing is its rotation. And let's just say enemy prefab dot transform. Just take its rotation, which doesn't really matter. I mean, it's a sphere, so it does, the rotation isn't like, we could probably just use this rotation. I accidentally moved this down there. That was an accident, but that's okay. Let's move it back up here and put a semicolon. So there you go. We have an instantiation. What, where, which we're going to make into a variable pretty soon, and then its rotation. But instead of us doing like a set place where we want to spawn every time, let's make it so that our enemy spawns in a random spot. Let's go ahead and test this first. Let's do that before I get too far ahead. So I'm going to save this. Let's see if I can get it to spawn correctly. Make sure that works. So it's saved. So two things I need to do. Since I'm working with a prefab, I need to prefab my enemy, and I need to add this script to my manager. So let's add the script. Click on your spawn manager in the hierarchy and add the Sumo smod script. And it needs to know what game object. We don't want to grab the one in our hierarchy, because if the server falls off or gets destroyed, it will go away from here. So let's go get a prefab. Well, we don't have a prefab folder, so I'm going to plus, make a folder called prefabs. In that folder, I will drag my enemy into here. Drop it in. Great. And I could probably delete the one that's... Actually, instead of deleting, I want you guys to get in the habit of just turning these off for now, in case we need it later on. So over in the inspector, there's a little check mark. You can click it, and it's just not really being seen by the game right now. Back on my spawn manager, I will take this enemy and drag it into here. And let's press play, and it should spawn when the game starts. Bloop, there it is. Great. So that worked, but we want to spawn in a random position so that we don't know where the enemy is coming from. Like, we can always predict now that it's coming from here. Okay, so to make a random spawn, I guess we need to go make a variable for that. So up here at the very top, line 7, I'm going to press return. I'll press it twice so I have a little room. Let's make a, I think we just need to make a private vector 3, since we're talking about an XYZ position. And let's go ahead and like initialize it. Oh, we're going to give it a name. Let's just call it random position is initialized equal to a new vector 3 and we need to say what that is, but we need to come up with some random numbers to go there. So I'm just going to put a semicolon here. This is not done. We're going to have to go back in and put in our XYZ in this bracket, but let's make it so that it is a random position. So let's set those numbers in our start method. So under my instantiate, when the game starts, let's go ahead and make a variable float to represent our spawn position on the X. And let's go ahead and do what we've done before. When we've done randomness, we've just said random dot range, so somewhere between these two numbers. And so for now, let's just go ahead and put in a number. How wide is this? If this is 0, I'm just looking, so you don't have to do this with me, but I want you to figure out how I come up with this number. I'm going to move this. So right now it's at 0. If I move it all the way over here, it's about, it says 11. So what if we go like 9? 9 looks good here. Let's go this way. Yeah, 9's pretty good. Let's do from 9 to 9. And what I'm doing is trying to figure out whereabouts would I want this to start. I don't want it right on the edge. I want it to stay at the end just a little bit. And so no more than 9. So -9 and +9 on the Z and the X axis. So if I go, let's move it on the X axis. Yeah. So somewhere between in this square, not Y, because Y would put it in the air. So I'm going to go back and set this to 0 on the z. All right, so we know we want to be within -9, comma, +9. And the same thing with our z. We want to create a number that holds all of the possible, nope, I'm spelling that wrong, capital Z, equals random dot range -9, 9. Now, we know that we don't really want to have numbers held down here. And since these are all the same numbers, these can be stored as a variable at the very top. So let's just create line 8. Let's replace those 9s with, what do we want to call this? Let's call it as a private float just call it range number. That's what I'm going to call it. And I'm just going to set initialize it equal to 9. And down here, every time I have a 9, I'm just going to put in range number. So negative range number to positive range number. Same thing here. Negative range number to positive range number. So once again, we're just trying to keep all of our numbers and things stored outside of this. And then if we want to initialize in our start, we're doing it here and replacing those numbers. So this right here, this new vector 3, is going to be from our spawn position x. So somewhere between -9 and 9 is going to spawn in the x position. So spawn. Oh, you know what? I need to put it in front of it, on top of it. That does matter because it won't be able to. Let's do it like that. See, that makes a difference. Spawn. I wonder why it's not seeing it. There it is. Yeah, it has to see it above it. This is one of the few times where order does matter. I can't put it after the fact because it will instantiate then set the number, but we want it to set the number then instantiate. Even though this happens within fractions of seconds of each other, we want to do that. And then our z, same thing. Let's put in spawn position z. So what we should get now is, why is this random position here? Oh, you know what? We're going to do this up here at the very top. But for fun, let's go test this out, make sure it works. Because we don't want to hold this 0 down here. Sorry. My end goal is to put these spawn positions up here and then put just random position in this slot. So we're going to hold the variable at the top. Okay. Is it updated? I think it is. We're going to press play. And it should randomly, okay. Let's try it again. See if we get a random position. There you go, we did. It started right on our player. We might need to make a way so that it doesn't hit our player. We can change that random range number. But let's do that later. Let's not get overcomplicated right now. So we like this. So let's just go ahead and change this up here to spawn. Position x 0, comma, spawn position z. Won't see it because we're initializing it later on. So how about we let's make a new method to hold all of this. You know what? Before we make the new method, let's put this down here. Like right here. Press Z. There you go. And this does not have to be private anymore. And we're getting a bunch of errors. What did I delete on accident? There you go. There you go. That looks better. So random position is set to pawn position x 0, pawn position z. So now I can just delete this because this is the same thing, right? So random position is this. Delete random position, not number. random position. Okay, save that. Let's make sure that works. So we should still have it should be functioning the same way. We're just trying to clean up the code a little bit. There you go. That's spawning randomly. Let's try it again. Where are you? Right there. That looks good. So we never know where they're coming from. That's good. Instead of it doing all this in the start method, let's just make a method down here at the bottom, like our own method, and have it call it in the start. So let's make one called. So let's make one that holds this information. Like instead of all this trying to do everything in the start method, let's just make it in a method that then will hold a number and put that number into here. So let's do a void and vector 3. And let's give it a name called I don't know. Generate random position, and let's add an argument there. Okay. So we're getting like this warning message here because this is not returning any information. So normally when we do a start, it just executes a line of code. But whenever we do a vector 3, it's looking for us to put something out of it, like to return something is what it's called. So until we fix that, we're going to get these red lines. Basically, let's copy this. So Command X, paste this in here. That hasn't fixed anything yet until we put in the next line of code, which is return random position. The last thing is that is still angry because normally when we start a method we've used void, but since we're trying to return some information, we have to just make it, basically this method almost functions like a variable. We just need to say private vector 3, and there you go. So this information is looking to put a vector 3 out. So whenever you make a method like this, almost like a variable, it's looking for this information to come out of the method. Opposed to these, this is just telling you when it happens. So void is like, oh, nothing is supposed to come from this. No information. It's void. Just execute this line at this point. This is saying, oh, we're supposed to generate a number here. And this is supposed to return our random position. So instead of random position up here, we will just tell it to generate random position there. I think that's what we want to do. And that should fix that. So it looks like we've worked really hard at doing a lot of the same thing, but what we're doing is making our code a lot more flexible once again, and that'll be useful because in our next video, we will be making it so that we have waves of enemies. So before we walk off, I'm going to save this spawn script and check and make sure that this is working. So it will instantiate what, where, which is a method that's telling us where, and then the rotation. Let's check and make sure that is the case. Boom, works, and works. Okay, great. I will see you in the next video.